Just as the most prominent distribution in univariate statistics is the normal distribution, the most prominent distribution used in multivariate statistics is the multivariate normal distribution. There are two different ways to define multivariate normal distribution, via PDF and via linear combinations. We shall start with PDF. In order to define a p-dimensional normal distribution, we start with a vector mu in Rp and a p cross p positive definite matrix sigma. Then the multivariate normal distribution with these as the parameters is written as np mu sigma. Its PDF is this. It is hard to grasp anything from this rather complicated form. Let's look at the bivariate case to have a feel for the PDF. We shall start with mu equal to 0, 0 and sigma equal to the identity matrix. Then the graph of the PDF is a surface like this. It's a nice bell-shaped dome curve. Not a curve, but a surface. It's like a tent. It just looks the same from all directions. The peak is situated just over the origin. Indeed, the mu parameter controls precisely that. If mu changes, then the dome just follows it without changing shape. The peak always remains right above the point mu. The role of sigma is somewhat more involved. To appreciate this, imagine horizontal bands drawn like rings all over the dome. If you look down from above, they look like circles centered around mu. These concentric rings are called contours. These concentric rings are called the contours. They are like the result of slicing the surface horizontally at different heights. For a moment, think of the contours as 2D, drawn on the xy plane. The sigma matrix controls the shape of the contours, that sigma matrix. Currently, sigma is the identity matrix. If we increase these diagonal entry to 3, then the circles turn into ellipses. If you now increase the other diagonal entry to 3, then we scale up the other axis of the ellipse as well. Here the contours are again circles, but the circles are bigger. This means the dome is now more spread out. Since the total volume under the PDF must remain 1, this implies that the PDF has now lost some height. It is now flatter than before. Let's now understand the effect of the off-diagonal entries, both of which must be equal as sigma is a symmetric matrix. When the off-diagonal entries change from 0 to say 2, we get a shear like this. Notice how the ellipses get squeezed obliquely. If the numbers change in the other direction, say from 2 to minus 2.95, the shear also reverses direction. Notice that if we decrease the off-diagonals a little bit more to minus 3, then the ellipses will get squeezed into a single line. Just at that point, something shocking would also take place. Sigma will not remain positive definite. It will become singular. If you put minus 3 here, in that case the determinant becomes 0. So the PDF, which uses sigma inverse and also divides by the determinant of the sigma matrix, ceases to exist. What does that mean? We shall discuss that in the next video.